Okay, good morning. This is the second lecture in natural gas for the energy economics course. This will follow along or follow directly from the previous lecture where we discussed natural gas markets, an introduction to natural gas markets. And today we're going to talk about the welfare and distributional impacts of the shale gas boom, or fracking, in other words, fracking. This lecture is a little shorter than the previous one. The two of them should combine to make about two 50-minute lectures, or two of our class periods. So let's get started. What's the agenda for today? We're going to finish discussing oil and natural gas market integration, and then we will look at the winners and losers from increased natural gas production. In other words, what are the benefits and costs of the fracking boom? Okay, so let's just remind ourselves what we're talking about. The U.S. has had remarkable growth in its oil production in recent years. So the blue line is U.S. oil production. This is largely due to the fracking boom relative to Canada and Mexico. We also saw that there's large natural gas price variation across the world. So the red is Japan, the orange is the U.S. The U.S. Natural gas prices have been in decline since the fracking boom took place. The point here is that the prices do not move together, do not necessarily move together. They probably move together to some extent depending on global economic cycles, but they're not moving together nearly to the extent that oil prices are. And why not? So why are there large price differences for natural gas but not for oil? Natural gas is more expensive to transport. We talked about this in the last set of slides. It's a gas. It can't be contained as easily as oil. There's two alternatives for transporting natural gas. There's natural gas pipelines, and then we can also condense it to a liquid by lowering its temperature to negative 260 degrees Fahrenheit, which is quite energy intensive. The U.S. is a very limited participant in the world natural gas market, so that's what we were looking at when we compared, or we did a stylized example of U.S. and Mexico natural gas trade, where we thought about what would happen if the U.S. expanded pipelines to Mexico. The notes for that are posted on Canvas, handwritten notes, so you can take a look at those if you want. If my drawings on the whiteboard were too difficult to understand, still getting used to this whiteboard thing, the electronic whiteboard. I think I've got it figured out a little better today. We'll see. So the natural gas market is not globally integrated, and that's important. So the question for today is, who were the winners and who were the losers from the fracking boom? The winners were electricity consumers. Of course, the fracking boom caused natural gas prices to decline. So that means that electricity prices went down as well. Electricity's at least in places where electricity is largely produced with natural gas. Who else won? Manufacturers that use natural gas as an input to production. So we talked about some of those in the last set of slides as well. Manufacturers that require heat are definitely going to be users of natural gas. So glass production, steel production, aluminum production, all of those require heat, and the heat comes from burning natural gas. Shale gas producers as well are going to benefit. Shale gas meaning the fracking industry. Who are the losers? Coal producers, owners of coal generators. We saw this at the end of the electricity market section of this class. We saw a paper where the authors estimated the effect of the natural gas boom on coal production and found that A lot of the decline in coal production in the last 10 years or so can be attributed to the declines in natural gas prices. So natural gas is essentially pushing coal out of the electricity market. Owners of wind and solar generators. Why would the owners of wind and solar generators actually be losers in this scenario? Well, when electricity prices are high, that's an incentive for alternative technologies to enter the market. Even though wind and solar is basically zero marginal cost, there's large capital costs to starting up a wind farm or a solar farm. Maybe not as much as a nuclear power plant, but the average cost, the capital cost given the megawatt hours that a wind farm can produce or a solar farm can produce, especially given intermittency with clouds and wind not blowing, those average costs are still fairly high. And so the wind and solar generators actually benefited from higher electricity prices. There was more room for them to enter the market. When natural gas prices decline, this actually pushes out coal and wind and solar generators. So wind and solar are going to depend on subsidies for renewable production or renewable portfolio standards or something similar that requires states to use wind and solar or renewable production in place of conventional fossil fuel production. They're going to require that in order to become profitable when natural gas prices decline. The other losers are conventional natural gas producers. We'll see that in a couple of slides, but states with a lot of conventional natural gas, not fracking, not shale gas, but just natural gas from conventional sources, they're actually going to lose in this case because, well, natural gas prices are declining. Their marginal costs don't change, and so their margins are decreasing. Okay, so there's a paper that actually estimates the welfare gains of the fracking boom. What do we mean by welfare gains? Consumer surplus and producer surplus. We are for this exercise, this paper does not account for the social costs. So we will talk about those in a little bit. But first, let's focus on the private costs. So what are they first looking at? They're looking at consumer surplus gains from the natural gas boom. And they're finding they're not evenly distributed across the country. What do I mean by consumer surplus gains? Let me just pull up my whiteboard. All right. Okay. Consumer surplus gains, all they're talking about here is we have a regular supply and demand equilibrium. Consumer surplus is the area that I've marked there, CS. It's the area above the equilibrium price up to the demand curve. They're saying in this paper, they're going to estimate the gains from the shale boom or the decrease in natural gas prices from fracking. So how is that going to come about? Let me give you, that's going to be an outward shift in the marginal cost curve. So the marginal cost curve is going to shift down or shift out like that. So that's going to lead to an increase in the quantity consumed, Q prime, and a decrease in prices. That's what we see. And then what this paper is estimating is the change in consumer surplus from this shift in the supply curve, or the marginal cost curve. So they're going to be looking at consumer surplus before, let's do blue. Consumer surplus before the fracking boom was this area here. Now we have an addition to our consumer surplus. Let's do it in rainbow. Additional consumer surplus is going to be all of this here. So the estimates that they are getting at are the quantities they're estimating are the area there in rainbow, the area above the new price up to the demand curve. Let's look at that. Yeah, not that. Here we go. So the change in consumer surplus before the spillovers by region, that's what this table is giving us. Let me pull up my slides. Okay, so who are the winners and who are the losers? What states have won and what states have lost? The lowest consumer surplus is going to be in the South Atlantic, for residential at least. That's mostly due to the type of electricity that's being produced there. So most of the electricity in the South Atlantic is going to be coming from coal. That's the coal region. So those consumers are not benefiting terribly. The ones that benefit the most are the East, North, Central, and those are the areas where most of the electricity is being generated from natural gas. So it's fairly logical that the East, North Central, where most of the electricity is coming from natural gas, is going to see the largest change in the marginal cost, which is going to be passed along to the consumers. How about in industrial? Industrial largest benefits are coming from the West, South, Central. That's potentially where a lot of manufacturing that uses natural gas takes place. How about how have the reductions in natural gas prices been passed through to end users? So how, in other words, what are we looking at here? Okay, so pass-through is defined as the change in prices over the change in marginal cost. Why do we care about this? So prices are declining. In a market that's not competitive, if you're a producer in this market, if prices are declining, you want to keep those benefits. Your marginal costs are declining. You would hope that your output prices stay the same, because that would mean that you can benefit from the decline in marginal costs without passing the savings onto the consumer. So if pass-through is less than 1, in other words, if the marginal cost declined by $1 and we see the output prices declining by $1, that's pass-through of 1. And the prices are moving 1-to-1 with marginal cost. But if we see the prices declining less than $1, then pass-through is less than 1. Or in some cases, if the prices, if we have a tax, and let's suppose we tax gasoline by $1 per gallon. It's a fairly large tax, but suppose we did. That would mean that the marginal cost of producing gasoline go up by $1. We would expect in a competitive market that the prices would also go up by $1. The prices you pay at the pump would go up by $1. But in some cases, that might not be true. The prices might go up by less than $1, meaning pass-through is not 100%. Or prices might go up more than $1, in which case the prices would pass-through would be greater than 100%. Why would that ever happen, and what's the consequence? Well, if prices go up by more than $1, then the producers are benefiting quite a lot. They're actually benefiting from a tax, which is fairly strange. It can happen, but most of the time in a competitive market, pass-through is going to be 100% or 1-to-1. So this paper says, let's look at the pass-through rate of the natural gas price declines. They find each of these numbers in this table give you pass-through rates to residential, commercial, industrial, electric power prices. These are 2 models, ordinary least squares and 2-stage least squares. You can kind of forget about those 2 models for the moment. The takeaway of this table here is that the pass-through in most sectors is statistically indistinguishable from one. The mar or the null hypothesis in this table should be the coefficients are statistically equal to one, and they fail to reject that null hypothesis in all cases. So that suggests that the pass-through is equal to one, which means that the market is competitive. It's not an oligopoly. So that's good. We know that we don't have to, when we write out our consumer surplus and producer surplus um, um, graph, we know we don't have to deal with market power. We're dealing with a competitive market. So how did the producers fare? Producers in the shale gas states are better off overall after the development of shale gas. So that's not entirely true. Producers in predominantly shale gas states are better off. So let's look at what states those are. We have a change in annual producer surplus that's positive in Pennsylvania, where the marginal producer is a shale gas producer. That's where the Marcellus shale gas field is. We also see that in West Virginia, and we see it in Arkansas. These are states where the natural gas production is predominantly coming from shale gas. Conventional wells have either been tapped, or they just haven't, or have been either conventional wells have either been um, extracted to the point where they're dry, or they haven't been extracted at all, or they don't exist. So Pennsylvania, we've extracted most of the conventional oil, or the conventional oil is off limits because it's under private land. And so the marginal extraction at this point is shale gas, and so Pennsylvania is benefiting from this. Other states like Texas, you might expect Texas to benefit from the fracking boom, but actually it didn't. At least producers didn't, and that's because there's a huge quantity of conventional oil and gas that's produced in Texas, and so that the decrease in natural gas prices for the conventional producers comes at a loss for them, and so that loss outweighs any benefits that are associated with new fracking producers. So Texas, let me restate that. Texas has a huge supply of conventional natural gas. The conventional natural gas does not benefit from the fracking boom. They still have the same marginal cost, but when natural gas prices decline, their profit margins decrease. So they're losing from the fracking boom. There are some producers in Texas that benefit, shale producers in Texas that benefit from the fracking boom, but they're not enough to outweigh the losses to conventional producers. So we see some producers benefit, some producers do not. Some states benefit, some do not. Some industries did not pass through the surplus gains. So let's look at this graph is intended to show you that not everyone is treating this the same. So some industries did not pass through their gains. So I was saying potentially if we might have a situation where pass-through is more than 100%. Well, this is a case where pass-through did not even occur in the ammonia and fertilizer industry. So what this graph on the right is showing is the price of Henry Hub natural gas in orange. You can see it declined. This is basically the benchmark price for natural gas in the US. It declined around 2011 when the fracking boom started to take place. But ammonia, which uses natural gas as an input, the prices of ammonia did not decline. In fact, they went up. That's the green line there. Those prices went up during the same period. So that means that ammonia manufacturers were profiting from the decline in marginal costs due to the decline in natural gas prices. So some industries are not being fair to their consumers. They're not passing along the savings to their consumers. So overall, what were the impacts of the development of shale gas in the U.S.? Natural gas consumers were better off by $74 billion per year. In particular, manufacturing industries that use natural gas as an input increase their employment and investment relative to other industries. So, you have if you're a an industry that uses natural gas as an input and your marginal costs decline because natural gas prices decline, you can then take those savings and invest them in capital or invest them in employment. So this is a boon for the economy, um, if that if manufacturers actually invest in capital rather than sending it sending the proceeds off to their stock shareholders. In total, natural gas producers were worse off by about $26 billion per year. So if we look back at that table over, let's look at the producer effects. Some states actually benefited, but most states most states were hurt by the fracking boom, at least in terms of producer surplus. So on net, producers were worse off by $26 billion per year. And the private welfare. So in total, we can say, what's the private cost benefit analysis here? Let's take the $74 billion consumer surplus gains, subtract off the $26 billion producer surplus losses. Net private benefits are positive. So private welfare effects are positive, but we are economists. We need to think about the social benefits as well. We need to think about the social benefits and costs. So overall welfare will depend on the externalities associated with increased natural gas production. What are those externalities? What were the environmental externalities associated with higher natural gas production? What are the effects on the global climate? Additional methane leaks through the supply chain. Methane is a very potent greenhouse gas. Um, so this is bad. But what is this offsetting? We need to ask ourselves the question. Um, there's additional methane leaks from increased natural gas production and transport, but what is this offsetting? Well, it's going to be offsetting coal production. So it depends on whether or not the net social benefits of natural gas production are positive, depends on how much we are offsetting, how much greenhouse gas emissions we're offsetting with natural gas production. The substitution of coal with natural gas for combustion in both electricity production and industrial, well, we don't really use coal anymore for industrial manufacturing, so mostly in electricity generation. That's going to reduce greenhouse gas emissions. That's good. But what happens to the coal that's no longer burned in the US? Is it exported or does it just sit in the ground? If it just sits in the ground, then great. We've completely offset the emissions from coal. But the coal producers aren't going to sit there idly and say, okay, darn, I lost um, I, I don't have anywhere to sell my coal. They're going to look to the international market for to sell their coal. Who buys coal? India and China and Africa. So what is this doing? It's lowering the price of coal on the global market, meaning more coal in other places is burned. So we're actually not really offsetting the coal production, the coal greenhouse gas emissions by uh, decreasing coal production in the United States. So that coal is just being shipped elsewhere. Really, the losers in the United States are the power plants that burn coal, not the coal extracting companies. What about local benefits and costs, social benefits and costs? The local environmental effects. Water contamination during fracking process or from wastewater byproducts. So every time you tap a shale gas well or a fracking well, you're pumping, I think, around 30 million gallons of water into the well. That water is mixed with chemicals and it also comes up contaminated with natural gas and oil. And so that water needs we need to do something with it. And typically that water just sits in um, ponds near the fracking wells, which is not good. That's dirty water. We can't use it. It if it leaks into the groundwater, it will contaminate the groundwater, which is bad for irrigation, agricultural irrigation. It's also bad for local drinking water. There's local air quality effects. Many people have done studies on this. We have a great atmospheric sciences department here at CSU. They they've done a lot to study the local air quality effects of fracking sites. And there's increase in traffic around sites. So maybe we see um, more trucks and so forth going to fracking sites, which could cause local congestion, but it could also cause noise pollution. And then earthquakes associated with wastewater injection. So when we put water, or the process of fracking is pushing water into fissures in the ground at high pressure. This is actually causing earthquakes in many locations. We'll see that in the next slide. It's difficult to quantify the welfare effects associated with the local environmental externalities. So a lot of this is sort of, we know they exist, but we don't know exactly what they're worth at this point. So we don't really know whether or not the fracking boom has been net positive or net negative. So, for example, in terms of the earthquakes, Oklahoma, one of the places with the largest um, amount of, or the largest increase in fracking over this period, Oklahoma had more earthquakes in 2015 than the rest of the continental U.S. combined. So, let's look at the end here, or prior to the fracking boom, Oklahoma had virtually no earthquakes. Now look at post 2011 all the way up to 2016. The number of earthquakes has substantially increased. Um, this is uh, we can't prove that this is coming from fracking, but it's pretty clear. Um, there's a strong correlation in the number of earthquakes and the increase in the number of fracking sites in Oklahoma. Should we be concerned about this? Hard to say. All right, wrapping up oil, natural gas, and electricity, and leading into the next section of the class. So the three sectors are intertwined. Electricity is produced via natural gas. Oil is used for transportation, but oil extraction and natural gas extraction are inseparable. This is just my thoughts on how they're intertwined. We could probably brainstorm many reasons that oil, natural gas, and electricity are all intertwined beyond these bullet points here, but these are my thoughts. Oil extraction and natural gas extraction are inseparable. Oil is used for transportation and for manufacturing, of course, but natural gas is used for electricity production and residential heating and manufacturing as well. The shale boom caused natural gas prices to fall, which caused electricity prices to fall in some locations, which pushes coal out of business. It's actually bad for renewable production as well. Lower prices mean less room for new technologies. With renewable production, we're going to see cleaner electricity in terms of environmental externalities. Cleaner electricity and more renewable production is going to decrease the cost of electricity, which is ultimately going to make electric vehicles more attractive. As more electric vehicles come online, then the demand for oil is going to decline. When the demand for oil declines, then the supply of oil is going to decline, which means the supply of natural gas is also going to decline, which means that the price of natural gas is then going to go back up. So, in the long run, it's hard to say what this is going to do. So cheaper electric prices Electricity prices for natural gas production might make electric vehicles more attractive. I just played out the long run scenario there. We don't. It's hard to say how that's going to end up. Um, my guess is that we will see um, we'll see more renewables entering the market. Renewable electricity production. The price of electricity is going to stay fairly low. Um, which means that electric vehicles are going to become more and more attractive, especially as um, um, we hope the um, the economy starts to think about environmental externalities, and so that's going to lead to a decline in oil consumption in the U.S. at least. Um, so a decline in oil prices around the globe, that probably means more oil consumption elsewhere. So our decline in oil consumption is going to be offset by an increase in oil consumption in other countries. Um, the benefits and costs of changes in the energy sector ultimately depend on the externalities associated with production and consumption. This is the hardest part of calculating the benefits and costs. We saw that this paper today calculated the private benefits and costs of the fracking boom. The hardest part to quantify are the social benefits, the environmental externalities, and that's where we're going next in this class. So next up, economic welfare of energy production. Economic welfare meaning the private benefits and costs and the social benefits and costs. The optimal policies for addressing the social benefits and costs, basically the social costs, the environmental externalities, and then finally determining the appropriate taxes on externalities. And that's where we're going. I will see you in a day or so.